Hi everybody, welcome to the Server 4.0, a new twist and old favor. Okay, this is the standard slide. I'm not going to talk about this. I'm Shing Chen. I'm a Servlet 3.1 and 4.0 co-spec lead. I'm also working on Servlet 3.0 implementation and the security JSR, JACC, and the JASPI. So I will let Ed introduce himself.
All right. How you doing? My name's Ed Burns, and I'm very happy to be here giving the Servlet 4 talk. This has been many years of Java 1 trying to get the Servlet 4 spec done and the Java EE8 spec done. It's been quite a long journey for both technical, business, and organizational reasons, but we're happy to have it finally done. We think there is a lot of great stuff in the spec, not just in Servlet, but in all of EE. And I hope to convince you of that today. Xinghua and I hope to convince you of that today. I think this is set up to auto-advance. That's what's doing me in here. Oh well, I have to get that fixed. Yeah, I have to set that up. Hold on. That's terrible. Slideshow, setup show. Why is it doing that? Manually. All right. Play from current slide. Sorry about that. So I've been doing specs for a while, JSF and Servlet spec leads, and also been an expert group member for a lot of different specs. Written a few books about Java and a lot of conference speaking on this topic. And with the coming of the Eclipse Foundation and the handing off of the Eclipse Foundation, which you'll have quite a bit of detail on later, I hope to still be able to do that, but in collaboration with whoever's working on it in the community. So you've got a lot of talks to choose from. I'm very honored that you chose ours, and I want to make that investment worth your time. A bit of high-level content on the contemporary and historical role of servlets, particularly taking a microservices perspective and a historical microservices perspective on this. Then the heart of the talk is mostly Xinghua giving the new features in Servlet 4, and then we'll have some stuff on opening up Java EE, and then a summary. So given that we only have 45 minutes for our session today, I don't know if we'll have time for questions, but I will be out in the Hacker Garden, and I'll be here all week. You can catch me there and also on the booth floor. So let's get into the historical portion. Micro, mono, oh no. I put up here J2EE Servlets, a very early Java microservices platform. What's the right way to start with this? All right, who was using servlets in 2000? Anyone? Okay. Who started using servlets in like 2005? Right. And who is still using servlets today? All right. So it's been around. Now this microservices term is a new thing, but there's nothing new under the sun really. And I would like to take a few slides worth of time to go through this definition, what I've determined to be a consensus definition of what microservices is, and see how well historical, old-fashioned J2EE servlets stack up with my own opinion and analysis. You probably might have a different opinion. This is something of a controversial topic too. So microservices generally are seen to be all small, a system that is a collection of services, each of which is small, loosely coupled, and can be composed, isolated from other services, very highly internally cohesive. It does one thing. Each service does one thing. Can be managed, deployed, and developed independent of the others, and is responsible for owning its own data. Let's look at each of these here. Now, on the small side, there's nothing stopping you from keeping your servlets small. One of the things that I learned in doing JSF, which is a web framework, is this challenge of trying to design something where it's easy to do the right thing, and harder, but not impossible to do the really wrong thing, because a lot of times you need to do the wrong thing to get the job done. So Servlet, with its very easy to use HTTP session and a lot of the properties that it offers in terms of being ubiquitously available and usually reliable, and then over the years, app servers have added clustering and failover to the HTTP session. So we did a lot of stuff to make it easy to really abuse that thing. So Servlet, in that sense, is small. You can do it, but you have to work a little hard to make sure it stays small. So I'll give that a maybe. Loosely coupled. Well, filters can compose pretty well. That's what they're designed to do. The filter chain concept is expressly designed to support composing. And if you have a system that's composed of a number of different wars, you can kind of consider them to be composable as well. Isolated from other services. This is generally not how people use servlets. So in the monolith, one of the reasons why the monolith is seen as a pattern to get away from is an outage in a servlet would prevent the entire rest of the call flow from executing. That's where the stack trace is. We get these big long stack traces in Java EE. My opinion on that now is we still have the huge long stack traces just spread about through all these different machines. But on the other hand, we have a whole huge raft of log science technologies that are out there to help you make sense of that large stack trace. So imagine if you could put your huge stack trace from hell from J2EE into something like Kibana and be able to analyze it and tear it apart like that. That might be kind of useful, but it's just a different approach that people are using now. So in terms of isolation, I would say I'll give that one a no. Highly internally cohesive, does one thing. Generally, servlets are used as controllers or filters that act on an HTTP request and either pass it on to some other service or send a response. So I would say yes, they can be said yes to doing one thing. Can be managed, deployed, and developed independent of others. This one, again, make it hard to do bad stuff, easy to do good stuff, and J2EE didn't do so well on this because it came up with this ear concept, and it let people be very lazy and just say, here is this one gigantic ear, it has 5 wars and whatever else in it, and it takes forever to deploy. And so that one is probably, I'm giving it a yes, but if you restrict yourself to just wars that you're deploying on different containers. And servlets responsible for handling its own data. Servlets generally don't have much in the way of data. This was always handled by other parts of the Java EE monolith. But whatever data a servlet does have, it's generally not shared with other parts of the system. So I'll give that one yes. For an overall rating of kind of, sort of, you can look at servlets as a very early microservices platform. But if it was the perfect microservices platform, then we wouldn't be where we are today. Things evolve and people change their tastes in response to economic trends and popular tools and what is seen as best practices. So talking about trends, this is one that I really like to talk about. We have been doing JCP specs for a really long time, and I think there's a proven track record of success. It's often held up as slow and ponderous and difficult, but you do get results. You do get representation. So in the particular aspect of servlets, we've always adopted and incorporated new features from industry trends and best practices all along. So we've had the packaging concept of WAR for forever. We added asynchronous I/O as that started to be more and more popular. When it came into the Java platform with NIO, we added that. I would also say that we had the ability to do a fully reactive application even before the reactive manifesto was put out there. Being able to have back pressure with the on data available on write possible methods. When dependency injection and inversion of control became popular with the advent of Spring and then CDI shortly thereafter, we added resource injection to Servlet and Java EE in general. And the latest trend, of course, is incorporating HTTP2 into the spec. So if you had a greenfield project from scratch, would you choose to use servlets on that project? Given the choice of any tools you had. It would be a stretch, right? But there are some reasons where you might want to choose to use Servlet for greenfield development in a microservices style. Let's say many enterprises have very strict standards as what is approved and what is not approved. A couple of years ago, I had the great pleasure to give a talk with a couple colleagues from Lufthansa Airlines, and they have this thing called the Big Book of Standards. That's probably not uncommon in many enterprises, and if you want to use a piece of technology in your solution, it has to be in there, and those solutions are all vetted by their corporate architects and have met the necessary security requirements and legal requirements and indemnification and support all of these important enterprise concerns. So you might be in such a shop, and you basically have to use whatever you're given in terms of J2EE or servlets, and you might want to take advantage of the microservices architecture but not be able to use all the different kinds of tools. That's one reason. It also could be that the team itself is maybe risk averse and trying new technologies but adventurous in trying new architectures. They want to take an incremental approach where let's do the new architecture using the old stack, and if once we get the architecture right, we understand how to do it, then we can take the architecture and apply it to the new stack. So there are some reasons why you would want to choose servlets for microservices. But the more common approach, I would say, judging by the huge number of talks on breaking up the monolith, I'm sure if you do a web search for breaking up the monolith, you'll see quite a few of them, is using servlets as a stepping stone to a more pure microservices system. So I mentioned ears that have wars, separating out those into separate wars. Another approach that people do is to stand up REST services in front of their existing wars, and then eventually decompose those wars so you just have the REST services, the pure microservices. So that's kind of the approach. So I'm going to hand it off to Shing here to give us the heart of the talk, the Servlet 4 new feature review.
Thanks to Ed, the introduction of the Servlet with the microservice. Now, let's try to take a look on a new feature in the Servlet 4.0. Now, before I go into the new feature, I would like to mention that all we've done in the Java EE is available in the github.com and /Java EE. You're welcome to try the sample in there. It's in the github.com Java EE /sample. In the samples there, you will see a lot of examples and to illustrate the new features in the Java EE, in particular, Servlet 4.0. Now, let's take a look on what the HTTP tool is. Now, we all know that HTTP tool is important. The primary focus is in the performance. And it has a lot of features to improve the page loading in the browser. How do they do this? Let's take a look. Now, first is binary framing. Now, in HTTP 1.1, the protocol is in clear text. And binary, no doubt, is more compact and efficient when it's transferred across the wire. And the second one is the stream multiplexing. Now, in HTTP 1.1, what you have is one request, one response, one request, and one response. And they also have a feature called HTTP pipeline ping in 1.1. Basically, it says that you can send multiple requests at the same time. So you can request 1, request 2, and request 3. But there is a requirement. The requirement is that the response needs to become in the same order of the request. So it must be response 1, response 2, and response 3. Now, there is a problem. What happens when it takes a long time to compute the response 1? In this case, response 2 and response 3 need to wait until response 1 is finished. And that is called head of line blocking problem. Now, in HTTP2, you can actually send the response in a different order. That is called stream multiplexing. What it means is I can send request 1, request 2, and then request 3, and then I can send response 2, and then response 1, and then response 3. So the order of the response is not important anymore. Even better, actually, we can split the request and the response into pieces. For example, you have request 1, request 2, and then you will send back part 1 of the response 1, and part 1 of the response 2, and then part 2 of the response 1, and then part 2 of the response 2. So this is a very nice feature of the stream multiplexing in HTTP2. And this allowed us to improve a lot in the page loading in the browser. We can see more about this later today. Now, the third feature that we have in HTTP2 to improve the browsing performance is the header compression. Now, if you try to take a look on the communication between a given browser and a server, you will notice that most of the time, a lot of the header they send across a wire is actually the same. A lot of the header actually the same. For example, what kind of content type or MIME type that a browser will accept, they need to send it across a wire every time. Now, this is a redundancy. Now, the way that HTTP2 do is you're allowed to do the compression in the sense that the first time you send a header, the second time you send an index of the header of a particular table which they agree on to the other side. So in this case, they don't need to send the whole header, they only need to send an integer. Yes, because that table is a private between the server and the browser and the server. It's not shared. Okay, the fourth feature is server push. And the server push basically is to say that, okay, you allow the server to push the data to the client. I'm going to talk more about this later. And finally, in the HTTP2, we always keep the connection alive. So in HTTP1, yes, you can keep the connection alive, but you have an option to turn it off. But in HTTP2, it's always keep alive, so you can send the data back and forth like this. Now, what happened in Servlet 4.0? In Servlet 4.0, if you use it, then you basically can leverage all the features in HTTP2. So you get the binary framing, stream multiplexing, header compression, and the connection, those things, free. This is transparent to the user. So the only thing that you have to do is to do something special about the server push, which I'm going to talk more. In HTTP2, we also have some flow control thing that is under the wire. You can say, I want to turn on or turn off the server push. This part is still working underlying the protocol. We are going to take a closer look on what happened. Now, before we go to the server push, let's try to review what happened in a classical case in Servlet. Now, you have a browser. The browser will go to get an index.html, and then they will return to the browser, go to the server, and then come back to the browser. And the browser will do several things. They will first of all look inside the index.html to do a parsing, and then they will find out, oh, I need a style sheet, and I also need a JavaScript. So after they do this parsing, they will send another 2 HTTP requests called get style sheet, and then return, and then get JavaScript, and then return. Now, this is a very common classical use case. Now, let's take a look on how server push can improve the performance in the classical case. Now, with this in mind, we are going to take a closer look. What is the server push? Now, if we code the wording from the RFC, they basically say server push allows a server to speculatively send the data to a client that the server anticipates the client will need, trading off some network usage against the potential latency gain. Now, what does this mean? Okay, you're allowed to send the data from server to the client, and then they are actually without the client asking for it. Okay, now first, what is the data? Can they be anything? No, it must be a HTTP response, right? Because the browser only understands HTTP response. Secondly, the response needs to corresponding to a request, right? Now, can it be any kind of request? It turns out not. Let's take a look on what the RFC said. Okay, the request that they correspond to is called promised request, and it have 3 criteria. The first one is cacheable. The second one is called safe, which means essentially read-only. The third one is your request cannot have a body. Now, with this requirement, you can look at the Venn diagram on the right-hand side. For the standard HTTP method, cacheable means post, get, and head. And safe means option, trace, get, and head. So if you want to be cacheable and safe, then it can only be get and head in this case. Of course, if you have a custom HTTP method, which is supported in the servlet, like you can define a method called foo, and in this case, as long as they satisfy the criteria of cacheable, safe, and without a request body, then you can still use the push method. Now, let's take a look on what we have done in the Servlet API. Now, as I mentioned before, the servlet, the data that we push across the wire corresponding to a HTTP request. So what we have an API called push builder is basically to construct the corresponding HTTP request. And so you can see the method like add header method, which is get or head or your custom cacheable safe without a request body. And then you have a query string, and then you can specify a section ID, and of course, you have to specify the corresponding URL path, and then you push. Now, given this push builder, you can construct the corresponding request. But still, you have to give me a way to try to get this push builder. We can get it from the HTTP request. Now, in the HTTP request, the API is called new push builder. Once you call this, you will get a push builder, and then you can manipulate and create a request. Now, I would like to mention 2 things for this new push builder. First, it's called new push builder. So every time you call it, you may get a new copy of the push builder object. Second is what happens when the connection, the client say, I don't want anything from the push, server push. Then they can actually turn it off in the protocol layer. In this case, the push builder will return null object. So every time you call a new push builder, what you have to do is you have to check whether it is null before you try to use it. Now, to illustrate this, let's take a look on a sequence diagram and to see what we can do to improve the performance of the common use case that I illustrated before. Okay, now you still have a browser, and the browser will go to get the index.html, and then they route it to a servlet, and the servlet internally, because this is the information you can put in the server, is okay, this is the index.html, and you know you're going to need the style sheet and the JavaScript. So what you have to do is like this. First, you get a new push builder, and once you get this, you return an object, and you return the object, you have to check whether this is null or not. Once you know that this is not null, then you can start to use it. Then you can set the path, and then push. And then once you push, you inform the container, and then come back. And then once you push the style sheet, you can do the same thing for the JavaScript. And then the server will send the push promise frame to the browser, and then eventually they will send the data, and then they will send the body of the index.html. Now, I would like to mention several things about this sequence diagram. First of all, we notice that the push builder is reused in this case. So you have one push builder, it was pushed twice. The first time is you push the style sheet, and then you also push the JavaScript. Now, if you share the push builder, there is advantages that you can actually pre-populate all the information that is common for these two HTTP methods. For example, this two I know is get, so I just put dot method get, and then they may share some common header like session ID or whatever. So you can set up everything in one push builder, and then you keep setting the path and push. Then you save the work, you don't need to reconstruct the object again. And another thing that I would like to mention is, in here, the diagram, I say I send out the style sheet and JavaScript. Here, we only send the push promise frame first. And then later, the server will send the body as a data frame. I think Ed is going to talk more about this in a concrete example. So now with this particular setup, what we have is like this. We save the two trips. We save the trip that is from the browser to the server again to ask for the style sheet and ask for the JavaScript. Now, this is a big advantage because in our previous diagram, when you have an index.html, you try to get the style sheet and the JavaScript, but we do not immediately get it. You have to get the index.html first, and then you have to pass the index.html. And then you have to look inside, and then eventually find that you actually need it. And then you put the request. So this causes a latency in this case. But in here, everything you know you need it. You just send it across the wire, and then let the browser pick it up. Now, I'm going to let Ed to do a demo on the server push.
Okay, so who is using any kind of Java server-side web framework of any kind, right? A lot of folks, okay. Keep your hands up, those that had them up. And if you're not using JSF, put your hands down. Okay, so we got some JSF users. The demo I'm going to show is based on JSF, and it's nice and simple. And let me get here, Chrome. This is, I'm running Glassfish 5. And I have the Prime Faces demo war deployed. And HTTP2 is enabled by default in JSF in JSF 2.3. So you're going to get the features if you're going over HTTPS. If you're not going over HTTPS on Glassfish at least, you're not going to get HTTP2. It has to be HTTPS for the server push to work. And so, let's reload this page, and this is just one of the Prime Faces components. And let's take a look at the Chrome net internals, localhost, and just look for push promise frames. These are, you can see it's making the request for some of the showcase CSS files. And there's quite a lot of resources coming in here. Some jQuery, JavaScript, there's some facelet stuff that's being templated and inlined here. So My point in showing that is Prime Faces 6 didn't have to rewrite itself to take advantage of server push. The fact is, web frameworks, not just JSF, but web frameworks in general, know what those resources are. They know the association between the pages and the associated resources. In the case of JSF, it's very strongly known because we have this whole resource loader concept where you define your resources to this thing and you say, this is my resource loader jar, or you don't have to have it in a jar, but you put it there, and then once you put it there, the server knows, okay, these are my resources. And the page that has a resource dependency on those resources knows that it's going to be serving them. So it's an ideally suited situation for doing server push. So that's the quick demo. We're getting short on time, so I'll just hand it back off to Shing to give us some more features.
Okay, thanks to Ed for the demo. And now, having talked about the server push, let's try to take a look at another feature called HTTP trailer. Now, trailer is not something that is for HTTP 2 only. We also have it in HTTP 1.1. So it's something earlier. Now, let's take a look on what it means. Now, let me quote a wording from the RFC. It says that the sender decides to send a metadata in the form of trailer fields at the end of a message. The sender should generate a trailer header field before the message or the body to indicate which field will be presented in the trailer. Okay, that sounds complicated. Now, let me try to extract the information from this statement. First of all, the trailer field is some metadata. Can it be anything? Metadata means header here. So it will be a header here, okay? Secondly, when I call it trailer, trailer is something that is sent at the end of the message. So you can see it's at the end of the message. And finally, for a trailer, the sender needs to inform the receiver that I'm going to send you a trailer field. In this case, they will send you a trailer header. Now, let's take a look on a concrete example, what it means. Now, you have a standard HTTP response. Now, in HTTP 1.1, in order to use the trailer, there is a requirement. You need to use the truncated transfer encoding here. So, you need to use the trunk transfer encoding here. And then in this case, I want to let the user know I want to give you a trailer. The trailer is sent at the end called foo::bar. Foo is the name of the trailer, bar is a value. And then, in order to do this, in my request header, I have to set a trailer::foo to tell them that I'm going to send you a trailer field with the name foo. There is a meaning of the RFC statement that I described earlier. So now then we have a question here. We know that all the trailer field will be a headers like this. Can it be any kind of headers? Okay, we can be full bar, but can it be any kind? It turns out, again, there is a requirement for this. It can be anything, but not the pseudo header. What is a pseudo header? A pseudo header for a request will be the HTTP method, the scheme, which is HTTP or HTTPS. The authority will be the host and the port, and also the path. So this information you cannot send in the trailer field. For the response, the status code, you cannot send in a trailer field. It must be sent earlier in the header. Now, this is a requirement that you have for the HTTP trailer field. Now, then we have a question is, why do people want to do this? Can you think of any use case why people try to do this? Yeah, good. Checksum is one of the things. Then the other thing will be the digital signature, right? And we have more. And we have one pretty popular use case recently. It's called gRPC, which is a RFC protocol developed by Google. And this protocol requires two things. They require the HTTP2, and they use the trailer field. And in fact, this feature is requested by the user from the EG discussion, and they bring up, they say, oh, we need to support the trailer field. So this is a good example of a cooperation between the expert group and us. Now, given we understand what is a trailer field and how important it is, we will take a look on what the Servlet 4.0 done for the API. Okay, the API consists of two parts. One is for the HTTP servlet request. The other one is for HTTP servlet response. For the request, we have two API. One is called isTrailerField_ready. The other one is getTrailerField. The getTrailerField will return a map, so it will like full bar, that kind of thing. And then for the HTTP servlet response, you will have a setTrailerField and a getTrailerField. Now, I want to emphasize that on the right-hand side, the response, when you say get and set a trailer field, you do not set a map object here. Instead, you send a supplier object here. And a supplier object is a new feature in JDK8. And basically, you only have one method called get here, and which is a functional interface. For a functional interface, it means that you can actually use it in the Lambda expression. And the reason why we give a supplier rather than a map is by the time that you try to set the set the trailer field, you may not actually know what you try to set. For example, this is a checksum. You don't know the checksum of your body until you compute everything. Now, if you try to set the trailer field earlier, then you have to know somehow, let them know what is the checksum. In this case, I will give you a supplier function, and the supplier function will keep track of the information and compute the corresponding checksum and put it in the header. Okay, now let's take a look on the HTTP server request. Now, can we just call the getTrailerField without calling isTrailerField_ready? Can we do that? It turns out we cannot, because the reason is, if you do this, by that time, the trailer field may not be ready. If it's not ready, you try to call it, you will get an exception. So the right way to do it is, you have to call isTrailerField_ready, and then you get the Boolean return, and then you check whether the Boolean is true. If it's true, then you get the trailer field, and then you return. Okay? Now, having said about the request side, we have the response. And then the response, as I mentioned before, you just have a set trailer field API, and in here, you will get a supplier. And the supplier will be a Lambda expression in this case. They will create a hash map, and then they populate the object here. Now, if you use the JDK9, there is a new feature called map off. You can actually simplify the expression here. I'll let you find out in the Java doc, or you go to a JDK9 talk, they will tell you. Okay, now notice that in the API on the response side, you have a get trailer field, and you also have a set trailer field, you also have a get trailer field. Why do we need a get trailer field? Because you're the owner who already set the trailer field. Do you already know what it is? Why you need to get it again? It turns out there's a reason. The reason is, this, as you can see in this example, you have a filter in front of a servlet, and you will call the do filter, and inside the filter, you will set the trailer field. And then, when you come to the servlet, by that time, someone already set the trailer field. And the servlet is also interested in setting the trailer field, but you don't want to override everything from the filter, right? You have to know what the filter does. So in this case, you get the trailer field first, and then you recover the supplier one. And once you know the supplier 1, then you can construct another supplier based on supplier 1, and then set it back to here. So the primary purpose of the get trailer field is to support this composite trailer field use case. Okay, this is about all I can say about the trailer, and there is something more about the servlet. I will let Ed continue about the mapping.
Yep, I'll be real quick on this. We're getting like 5 minutes left. The mapping discovery feature was entirely donated by the community member Arjun Times, and then we debated it and discussed it in the expert group. He's now working at Payara on the Payara server, and part of the micro profile effort, which is hopefully going to benefit from the EE Foundation thing. It allows for discovering how the current servlet was reached. It only works for servlets, not for filters. It accounts for all the various ways the container can invoke a servlet, which there's many, right? So you can invoke a servlet by the container applying the mapping rules, or the application code can invoke any of these methods here. And if they use that approach, then there's an associated set of request attributes that go along with that let you discover where it was before it came through getWasCrestEtcher.forward or include. So that's just in keeping with what we already had in the specification. When you ask the request, give me the servlet mapping, it'll return this immutable servlet mapping. It has an enum property, which will tell you what kind of mapping it was, context root, exact extension and such. Then it has some other Java Beans properties, the match value, what was the pattern that was actually matched, and the name of the servlet that was invoked. And if you have multiple servlets being called and you happen to call this thing, it'll give you, the name one will be the current one, the one that's currently executing. Some miscellaneous stuff. We had some encoding clarifications we did. On the request side, the URL paths read from the wire are specified to be in UTF-8. We didn't specify that before, although we do allow vendor-specific configuration for reading the URL path portion. Some clarifications on the encoding for XWWWForm URL encoded. We added a method setRequest character encoding to the servlet context. There is a new XML element that lets you set that as well. On the response side, we have the same thing, a method and an XML element. Okay, and I think you're going to take us out, right? Oh, we have one more switch to do.
Yeah. We also have some other feature in the Server 4.0. One of them is we add some API so that you can implement the Servlet API more easily. The first one is we have added in some default method for the listener, and the second one is in the filter init and destroy, and we also add the helper class for the generic filter and HTTP filter. And the only change in the schema in the web.xml is we add a new element called default contact root. In the past, we cannot do it. We are in the servlet, and you have to depend on the proprietary way to set the contact root. And we also add a new API to set the session timeout, which is in minutes here. And then you also have an API to add the JSF file, which is similar to the servlet, JSP file, sorry. Okay, I will let Ed continue.
Okay, I'm going to run through this because you're going to see this in the keynote, but there's one additional slide that I want to put. You'll see this in the keynote. But I wanted to give my perspective from the servlet side. And actually, if you were in the previous talk from Linda, you got most of this too. But the challenges I can see for servlet in EE4J, that's going to be the name of the thing in Eclipse. Servlet has always been revised in lockstep with the whole EE platform. If the stated objective of EE4J is to make it more agile, it's going to be hard to do that, right? Also, Servlet has extremely high backward compatibility expectations, and important Servlet EG members are not full Java EE vendors. So that question is going to have to be addressed. We've always kind of had this little dichotomy where Jetty and Tomcat, which are some of the most popular containers out there, are not full Java EE containers. You don't get EJB by default, for example, or CDI. And that was a difference between the so-called big full Java EE vendors, your WebLogic and WebSphere and Glassfish and Pear also. And there's also a very large number of implementations. So the Servlet has been a great example of the success of having JCP efforts, but it's going to be a challenge to have all those stakeholders. That's been my challenge over the years with Servlet EG, is to keep all these stakeholders in agreement, and there's quite a bit of difference of opinion, so we'll see how that goes in the foundation. And that's, as I said, more agile, flexible, open, compatible. You'll see that in the keynote. And that's the summary of moving Java EE to EE for J. And let's Shing Wai close us out with a summary of the whole talk.
Okay, as a summary, the Servlet 4.0 bring the HTTP2 to the Java EE platform. And this is a significant improvement in the website. And we are also backward compatible. And you can download the Glassfish 5.0 and try out the new feature in the Servlet 4.0. Now, one thing that I would like to mention is, right now, 5.0 only run on JDK8. It does not run on JDK 9 yet, and we are working on the version 5.01, which will run with the Java SE 9. Okay, thank you.